We talked about, well, what we have been talking about is parabolas, right? Graphs that look like this, that are the nice U shape, or the umbrella shape if they're negative. That is what we've been looking at. Wi-Fi's being a little glitchy, so we'll see how this goes. Today is such a relaxed day that I will be sitting down for the whole lesson, because it's not going to take very long, hopefully. I'm not even going to look at very many examples. Okay? We have two things we need to learn today. But first, a little bit of review. What do we call an equation this form? Does anyone remember? What form is this? It starts with an S. What form of an equation is this? Standard. Good job. Yep, standard form. Right here. Standard form. Right? That's what we've looked at so far. What we learned on Friday, for those that might have, Thursday and Friday, for those that might not remember as much, remember opposite of B over 2A. This gives us our axis of symmetry. That's how we find our axis of symmetry. We've got an equation in standard form. That also gives us our x value of our vertex. And then how do we find the y value of our vertex? Remember? Yeah, we plug our x value in, and then it gives us our y value. Nice. So that's what we talked about on Thursday. Now, today we're talking about another type of form. This is the first thing we need to learn, okay? Vertex form. Vertex form. And here is, yeah, this would probably be a good thing right now. So here is vertex form. Y equals A times all right, here's vertex form. It's okay. Letters just represent numbers. They're just spot holders. No big deal. Vertex form would be right here in this form, where our vertex, and it's called vertex form because the vertex of our parabola is h, so whatever value is right here, and k. What do we know about, we've already talked about this k value on the outside. How does that affect our graph? What does that do? That k value on the end. What? Oh, that's fine. Come on, what does that k value do? If we have plus 5 on the end, what does that do to our graph? Yeah, it moves it up and down, right? That k value moves us up or down. Now, what we're introducing today is this right here, this minus h next to our x. And guess which direction that moves our graph? Guess. What? Well, our k value moves us up or down, right? And if k is negative or positive, Skylar? Left or right, yep. Okay, so what's going on in our parentheses, that's right next to our x, that moves us left or right. And what's on the outside, that k value, like what we've been looking at, moves us up and down. Okay? So if I gave you something like which way would we naturally think that our graph moves? We know inside the parentheses moves us left or right. At minus 3, which way would we think our graph moves? Now, that's what we naturally would think, right? But the thing that we need to understand, and here's where things get a little bit tricky, is that x, and you'll find this all over algebra, and algebra 2 and everything, x always lies, Okay, like x is a liar. So we look at what's going on with the x right here. We think we would minus 3, but x is a liar. So we actually are going to add 3. Okay? So what we talk about all the time, like in Algebra 2, is that, switch colors. There we go. Is that this works with our y's, and y is legit, so y tells the truth, but x always lies, okay? X, we have to do the opposite. You'll also hear people say, like Mrs. Stone says, hello.
I think I left my glasses in here.
Oh, right there, next to Skylar?
Yes.
Sweet. I'm surprised you made it here without your glasses on.
Everything's just really blurry.
See, that was a lame joke, nobody laughed though. See you, Destiny.
Yeah.
So we would talk about undoing the x's and doing what the y says. I like to say that x lies and y, whatever's on the end, tells the truth. Okay? Good job. Now, what you could see that they would keep doing, or how they would add to this, is they would give you something that looks like this, right? That's something that wouldn't be too difficult to us. If we just look at what is going on with the x's, which direction are we going? And how many units? We're going 2 to the right. Yep, x lies. So we think we were going left, we're going 2 right. Now, how about up or down? What does that plus 3 do on the end? Up 3, yeah, just like what we worked on last week. That's most of what we're doing today. Okay? The last thing that they might do, yeah, is go like this. So we know that we are right 2, up 3, but what does this 4 do in front of our x? Our parentheses and everything. What does that 4 do? Yeah, it makes it grow super fast. Yeah, so it's narrower. Okay, so that 4 would make it grow really fast. Now, they'll ask you questions like, what is the vertex of this parabola? Our vertex, you can see, is at 2, 3. Our axis of symmetry is at 2. That is why we like vertex form, because we can quickly see what our vertex is. Okay, so that's why they call it vertex form. What questions do you guys have about what I just talked about? Yeah, Abby?
Will we ever do a positive one?
A what?
Will we ever do like a positive x?
Yes. Yep. It might be like x plus 2 in the middle, then we would go 2 left. Yep.
I just wanted to make sure. Like,
No, that's a good question. I just, for whatever reason, when I thought of an example, I just put the negative in the middle. But you will have positive, so then you go the other way. Any other questions? Amari, how we feeling? Pretty good? Okay. So that's thing number 1 that we have to learn today. Item number 2. Why is switching colors not working very good? I need to see if we actually call this something. No, we don't actually call it something specific. That's okay. How many questions of those are on your homework? Because maybe we'll get a couple of your homework problems done. Nah, there's only 4. Item number 2. Some things that they will do is say something like, well, let's start with this. When we see f of x, okay, when they say f of x equals, let's say it's like what we were working with, x plus 3 squared minus 10, okay? When we see f of x, what should we think of? It's the same as, yeah, just y equals, right? So don't let f of x freak you out or anything. Some problems that they will give you will look like this. They'll say, describe how the graph of g of x compares to the graph of f of x. So they'll give you a graph like this, or they'll give you an equation like this. G of x equals f of x minus 7. And they'll say, describe how the graph of g of x, so this new graph, compares to f of x. Okay? Does anyone have any idea of what that even means, or what we would look to do to compare those? What do you think, Layton? We look at what changed. Yep, and what, in this example, what changed? What happened? Right, the g of x moves 7 down, okay? It doesn't matter what f of x is. Like, they don't tell us what this f of x is. They don't tell us f of x equals, 3x squared or whatever. They do not tell us that. But what they're trying to get at, the point that they're trying to make, is that no matter what f of x is, if we subtract 7 on the end of it, then our graph is moving 7 down. So g of x, the way we would answer this is by saying g of x is 7 units down. Technically, we should say g of x is translated. What other types of examples would they give you? They also might give you one like this. Now, what did we just talk about? What do we know if our number is being added or subtracted directly with x? What's going on, Skylar? So it wouldn't be 7 down. It would be 7 in the negative direction, but it would be, well, I guess for you, it would be left. Okay? So if it's inside that parentheses with x, just like when we had, if we had this, that's really what it's talking about, is we're adding 7 to the x. Okay? So g of x is, keep forgetting the right translated. Translated 7 units to the left. Skylar did a good job recognizing that when we have x plus 7 and they're right together in the parentheses, that she recognized that x is lying and that we needed to do negative 7, but just got confused with if we go up or down or left or right. So we go 7 to the left. I know the notation's a little bit weird, but do we understand what they're kind of trying to get at? All right, last one. Let's do an example of this. What if they gave you one like this, where you're multiplying whatever f of x is, you're multiplying it by 5. What would that do to our parabola? I see a bunch of hands going like that. Skylar, what do you got to have? Yeah, make it grow faster. Exactly. So we would say g of x is narrower than f of x. Now, you can easily see how in these problems they might give you something like this, like a 1/4 in front, instead of a 5, and then you would have to talk about how it goes wider. But do you have any questions about that second thing that we looked at? It's just kind of getting you used to this notation of g of x and f of x instead of saying y all the time, instead of saying y equals all the time. But there are only 4 problems like that are on your homework. So not too bad. Your homework mostly focuses in on this stuff. If you have this down in your notes, good shape. Okay? Do we have any questions about any of that stuff we talked about? We're feeling pretty good. Like I said, it's not too much of a difference from what we talked about on Thursday and Friday.